Hello ASs, we're going to do exercise 9b now, and this exercise starts off with the following. There is a circle given to you with a triangle that runs through the center of the circle and does the following. Now what they want us to do is find the marked angles, and in this case the marked angle, sorry, everything's just disappeared here quickly, let's just go back. The marked angle is over here, but they also told us that this little angle down here was 40 degrees. Well, since we know that this over here is the center of the circle, we know that the two lines over here are radii and therefore they are equal, making this as an isosceles triangle, which means that must be 40 over there. Now you might be tempted to want to say, well, then the angle in the corner is 90, making the other angle 50, but that would be a little bit presumptuous at this stage because you don't know that it's 90. So rather what we're going to say is that the sum of the angles must mean that this angle must be 100. Okay, and that's because the angles in a triangle add up to 180. And we do know that there's a straight line here, making this line over here then, or this angle, 80, because it's along a straight line. But this is also an isosceles triangle, making this two equal angles in this triangle, so these two angles here must be equal, and therefore this must be 50 and that must be 50, which does prove that the angle over there is 90. And this is something that you, I suppose, could have gone with if you'd thought about the proof of the angle in a semicircle is always equal to 90 degrees. But there's another way of getting there without having to remember that proof. Okay, so that was number 1a. Let's go with question number 1b, which had the following picture. So we'll draw a circle again. And then we've got the following shape. Right, and they tell us that they want to find, I'll just have a look here nicely. Well, they've given us a 40 degree and then they want two angles. So they told us that this one over here is 40 and they want to know what is this one and what is this one. Okay, so we're straight away going to say that this one over here is 48 degrees, and the reason for that is that we have angles in the same segment. So if we started at this point over here and this point over there, we can go all the way along and make an angle over there, that's the 40, but we can do from those same 2 points, we can also form that angle over there, which means it must be equal because angles in the same segment are equal. And then we can say that since this here is the center of the circle, because I did mark that it goes through the center, then we can say that these two are radii, making that over there 40. And not that they asked us, but we could also then say that this angle over here is 40 degrees. Are you happy with that one? Let's go on to the next one. So the next one was number C, and C looked something like this. Another circle. It looks better. And we've got the following shape. Inside, they want to know what is this angle, but they told us that this angle over here is 240, which would make this angle equal to what? Well, since it makes a full circle around, 240 plus what is 360, the answer is 120. And since this is an angle at the center and that is an angle at the circumference, that must be half of that, so that angle must be 60. Are you happy with that one? Right. And that takes us to D, which looks as follows. So let's draw a circle again. And D has got the following. There's a line that goes through the center of the circle, somewhere there. And then there's a line that goes there, a line that joins up, and we've got a line going here, and we've got a line that does this, and then another line that does that. Right, so there's the picture. They give us that the angle over on this side is equal to 36 degrees. So that's this angle over here, 36 degrees. And then they want to know what this angle is, as well as what this angle is. Well, again, we're going to see these are radii. You're always looking for radii, because if you've got radii in a triangle, then you've got isosceles triangle making that angle over there 36, and that makes it 72, which means that this must be 108. Okay, now that is an angle at the center again. And does it go from an angle at the center from 2 points? Well, there's the 2 points over there. You can go to the center along those lines, but you can go to the circumference along those lines. So what is 1/2 of that? It must be 54. And that is number D. Well, that brings us to question number 2. So let's see. Question number 2 looks as follows. Now circle again, and they've given us a line across, another line here, and a line to the center, and a line that joins over there, and then they've got a line that goes here and a line that goes here. They've also given us some labels, so let's fold them in: A, B, C, D, and O. So this is A, B, C, D, and O. And then they also told us that they want us to find the angle X and the angle Y. So that's over here, X and Y. Now, they said write down the values of the obtuse angle DOB. Okay, so that will be the one at the center, and the reflex angle DOB. Hence prove that the opposite angles of a cyclic quad are supplementary. Okay, so they didn't give us any values, they just told us that the angles are X and Y, but they want to know the values of the obtuse angle DOB. Alright, so let's see, what have we got here? So first of all, what I'm going to do is I'm going to say that if we use D and B as 2 points to subtend from, okay, let's have a look here. There's D and B. This thing's being a bit crazy now. Okay, but D and B are angles that we can subtend angles from, and we know that if we go from D and B to the point A, so in other words along here, we get to X. But that means that the angle over here must be double, so that's 2x. Okay, 2x. Okay, so far so good. Okay, and we've also got y. So let's see, what about that angle y? Well, that angle we could also subtend from the same 2 points. In other words, from here. Just have a look here again. Oh, sorry. Undo that last bit of stuff here. Went a bit wild here. I was just cleaning the screen. Right. So we can see that if I subtend from D and B and I go to C, I get Y. But that would make this angle around here 2Y. Well, 2x and 2y around the center there must make a full circle, so they must be 360 degrees, which means that x and y, which are the two angles over here, must be half that. In other words, 180. But they are the two opposite angles of the cyclic quadrilateral ABCD. And there we've proved it. The opposite angles of a cyclic quad are supplementary, or add up to 180 degrees. Okay, so in the next section I'll carry on with the rest of this exercise, but there's the first two done for you. So I'm just going to stop the recording.